Be it remembered that on the 4th day of April, in the year of our Lord, 1826, and in the 50th year of the American independence, Messrs. Morgan, Lodge, and Fisher of said district hath deposited in this office the title of a book, the right whereof they claim as proprietors, in the words and figures following, to wit, Symmes's theory of concentric spheres, demonstrating that the earth is hollow, habitable within, and widely open about the poles, by a citizen of the United States. There are more things in heaven and earth, Horatio, than are dreamt of in your philosophy. Shakespeare. If this man be erroneous who appears to be so sanguine and persevering in his opinions, what withholds us but our sloth, our self-will, and distrust in the right cause, that we do not give him gentle meetings and a gentle dismission, that we debate not and examine the matter thoroughly with liberal and frequent audience, if not for his sake, yet for our own, seeing that no man who has tasted learning but will confess the many ways of profiting by those who, not content with stale receipts, are able to manage and set forth new positions to the world. And were they but as the dust and cinders of our feet, so long as in that notion they may yet serve to polish and brighten the armory of truth, even for that respect they are not utterly to be cast away. Milton. In conformity to the Act of Congress of the United States, entitled An Act for the Encouragement of Learning by Securing the Copies of Maps, Charts, and Books to the proprietors of such copies during the times therein mentioned, and also of the Act entitled An Act Supplementary to an Act entitled An Act for the Encouragement of Learning by Securing the Copies of Maps, Charts, and Books to the authors and proprietors of such copies during the times therein mentioned, and extending the benefits thereof to the arts of designing, engraving, and etching historical and other prints. One of the believers in that theory,
Sir, to you I would apologize for the liberties I have taken with your theory
and your publications in relation to it, which have made their appearance in the newspapers of the day. When I commenced this compilation in support of your doctrine of concentric spheres, I had no view to its publication. I had collected all the papers on the subject upon which I could lay my hands with the intention of investigating the theory for my own satisfaction. But the scattered and irregular order in which I found them, and in which they must necessarily appear in detached newspaper essays, published at different and distant times, induced me to attempt a methodical arrangement for the purpose of facilitating my own enquiries. When I had completed this, the same reasons, added to the consideration that you have not only invited, but solicited the investigation of your theory, declaring it as free as air to every person to make such use of it as he may think proper, influence me to conclude on publishing the result of my investigations. Having come to this determination, I have added a preface, an introductory chapter, and a few things in conclusion to make it look more like a book. As I have not seen all your publications in the newspapers, if I have not fully understood, or if I have misrepresented your theory in any particular, I assure you it has been done unintentionally. It has arisen entirely from my want of adequate information, and I hope you will, in the spirit of candor and good nature, pardon and correct any errors into which I may have fallen. Had an opportunity offered, and could I have done it with propriety, I should certainly have submitted the manuscript to your revision previous to its publication. However, as this sketch is only intended to elicit further investigation and can only live until a formal and systematic treatise shall appear from your pen, I hope you will permit it to pass as the pioneer to a more complete demonstration of your theory of concentric spheres? I am, sir. It often happens that those who have been early taught to believe a certain set of principles and doctrines as true, whether in philosophy, religion, or politics, adhere to them with the utmost pertinacity during the remainder of their lives. Any new theory or principle is resisted with peculiar energy, and however inconsistent or untrue their favorite systems may be, they are disposed to make principles and facts bend to them, and would sooner call in question the general and immutable laws of nature than the correctness of their own opinions. Perhaps this pertinacious adherence to prevalent and received opinions has retarded the progress of philosophic improvement more than the want of bold, original, and inquiring genius. In former times, those who cultivated science, or rather, those who were called learned, generally based their philosophy on the doctrines of Aristotle, which, as they had been taught to reverence them from their infancy, had become almost interwoven with their constitutions. Hence, though time has unfolded to us their errors during several centuries, suspicion never hinted their fallibility. The doctrine of the revolutions of the Earth and other planets, of gravitation, magnetism, and other properties now known to belong to matter, have each in their turn met with a strong opposition from the most learned men living at the time of their discovery. But, notwithstanding this opposition, in all ages, a few bold, inquiring minds have had the firmness to dissent from the established doctrines of the schoolmen and to lay the foundation of new systems, the correctness of which subsequent improvements in science have more or less demonstrated to the world. Although nearly 6,000 years have elapsed since man has been placed upon the earth, he yet knows but little of its formation. Notwithstanding all our enterprise, all our boasted acquirements and discoveries, its true form yet remains uncertain, and although admitted that it is not quite 8,000 miles in diameter, we still have never explored its extent. A space of nearly 40 degrees of latitude remains as little known to us as if it were a part of the surface of Saturn or an orb revolving round a star of the 8th magnitude. We know nothing of the inhabitants of those regions or what kind of animate beings exist in them. It was a prevailing opinion among the ancients, the correctness of which they for ages never called in question, that the temperate zones of our globe were alone habitable. The torrid zone, they imagined, was composed of nothing but sandy deserts, scorched up by the vertical and insupportable beams of a burning sun. The frigid zones, they believed, were begirt with eternal snows and thick-ribbed ice, which rendered them inaccessible to man and incapable of supporting animal or vegetable life. Hence, none ventured to approach them. Subsequent discoveries have, however, taught us the errors of the ancients. We now know that the torrid zone teems with organic life and possesses, in many parts, a population more dense than the temperate and is equally well adapted to its support. Nay, we even find the temperature of that region to be such that it contains mountains capped with perpetual snows, which the beams of a July sun do not dissolve. It has also been ascertained that the frigid zones are partially inhabited, but it seems that a certain timid dread, perhaps in part attributable to the prejudices imbibed from our ancestors, has prevented, nay, even the untutored savages who reside there tell us that other human beings reside yet further to the north, and animals are known to migrate in that direction. Reasoning then from analogy, and from what we know, we have no ground to conclude that such a vast extent of surface has been created by an all-wise providence for no other purpose than to be eternally clothed with mountains of ice. Such a conclusion comports not with the general economy we do know to exist throughout his works. We are constrained to acknowledge, notwithstanding our improvements in science, that, comparatively, we know but little of the economy of nature. Within a few years past, almost an entire revolution has taken place in the world respecting the philosophy of light and heat, a change which affects the theory both of their nature and of their causes. They are now believed to be two distinct things, and that the sun communicates neither, but merely gives activity, in some manner not yet known, to the principles, or matter, of light and heat with which our elements abound. If this be the case, as I believe is now admitted by the learned world, we cannot undertake to say that the intensity or the absence of either is necessarily dependent alone on the altitude of the sun under any particular latitude, or on our nearness to or remoteness from the center of the system. For aught we know, both may be connected with arrangements that require but few of the sun's rays to make them answer the purposes of organic life. For aught we can tell, the planet Georgium Sidus, which rolls 1,800 millions of miles distant from the orb of day, may, nevertheless, be favored with as brilliant light and as genial warmth as our little globe. And for aught we know, the interior of this planet, in the concavity of the spheres, under the equator, may enjoy the same light and heat that fructify and bless the equatorial climes on the convex surface. During a period of several thousand years, the ancients were of opinion that the earth was a perfect plain, at rest, and supported below by an unknown something, that it was bounded on all sides by an impassable barrier, and covered with the blue canopy of heaven, in which the sun, moon, and stars performed their diurnal revolutions for the sole use and service of a few frail mortals. They believed that the sun every morning rose out of the eastern sea, and in the evening plunged into the western ocean, that the stars were lighted up in the evening by some kind deity, and extinguished before the appearance of the sun. For ages none doubted the correctness of such a theory. At length, however, from an attentive examination of the regular appearances and revolutions of the heavenly bodies, some of the Babylonians adopted the opinion that the earth was spherical, revolving at regular periods round the sun as the center of the universe. In this, they were followed by Pythagoras and others, but those efforts of genius, for the most part, met no other reward than the execrations of the exasperated multitude. Such innovations were deemed an impious crime against the gods, and could only be atoned for by the sacrifice of their lives. In those times, the people of every nation, like the untutored Indian of our northwestern wilderness at this day, considered their own country to be situated in the center of the world, and they the most favored people. Even in later times, when the system of the Babylonians and that of Pythagoras were revived by Copernicus, and when new discoveries respecting the form and revolutions of the earth and other parts of the universe were made by Galileo, not more than 200 years since, we find an ignorant and bigoted world alarmed at such opinions. We find Galileo, that incomparable philosopher, cited before the court of Inquisition, accused of heresy and thrown into prison. The charge of heresy against him was supported by alleging that he maintained the two following positions, viz., 1. That the sun is the center of the world and immovable by a local motion, and 2. That the earth is not the center of the world, nor immovable, but that it moves with a diurnal motion. These positions he was not permitted to maintain or defend, but was ordered to renounce them, and was prohibited from vindicating them either in conversation or writing. However strange and impious these doctrines appeared at that time, subsequent ages have confirmed their correctness. When Columbus advanced the theory of a Western continent, he was ridiculed, persecuted, and contemned by nearly all the literati of Europe. It was an idea which had never before entered their minds. But, notwithstanding many of the important discoveries of the immortal Newton, at the time they were first promulgated to the world, were denounced as the splendid visions of a madman. But subsequent ages have done him justice. Much as we may feel ourselves elated on account of the new lights which have since been shed upon us by the further progress and development of science, yet when I reflect on the unkind treatment which Captain Symmes and his new theory have received in our own day, I cannot help fearing that we are still, in some degree, under the influence of the same feelings and prejudices which brought the earlier philosophers to the torture and the prison. This theory differs much less from the one now commonly received than the doctrines of those philosophers differed from the prejudices of the multitude in an age when everyone believed the earth to be as flat as a table, and consequently it is but a small innovation in comparison to what the theory of Pythagoras and Copernicus must have appeared to be in their day. Yet Captain Symmes has been constantly and almost everywhere represented as a visionary and dangerous innovator, and his alleged discovery ridiculed as the silly dream of a deranged imagination. But let us not turn our backs and give a deaf ear to him, or to the discoveries of any other man, merely because they are new and in contravention of our previously received impressions. True it is, novelty is frequently dangerous and hurtful, but on the other hand, it is often necessary and useful. Without it, we should still remain destitute of many of the greatest advantages we enjoy. Without the advancement of new principles and speculative ideas, neither ourselves nor any other people could ever have emerged from a state of savage barbarity. Without it, what purpose could our reason serve, which under proper regulations and by a gradual progress is capable of contributing so largely to the general good of society? Were it my opinion that Symmes's theory is one of the wildest and most ridiculous that ever entered into the brain of man, I would not refuse to hear him, nor by malevolent or satirical disapprobation attempt to discourage him, before I had examined and reflected upon it. By the examination of many speculative subjects abounding with falsehood, we are frequently enabled to treasure up some truths. Some of the first and most important discoveries in chemistry owe their origin to the midnight vigils of the alchemists who vainly sought for the philosopher's stone, and many valuable combinations in the science of mechanics have been discovered by those who wasted years in as vain a pursuit after a perpetual motion. I believe there are but few theories which do not contain much that is profitable. The man who has the ingenuity to advance new ones will be likely in the course of reasoning necessary to support them. He will often point out landmarks which may be useful to the future traveler. Whether then, is it better to crouch under the tyranny of prejudice or employ our thoughts and reasoning powers in the search of truth, though at the risk of deceiving ourselves, as our predecessors have done? Had it not been for a prudent boldness in advancing and defending new doctrines, the human mind must have remained to this day the sport of all the chimeras of the ancients. The exact shape and formation of the earth are admitted not to be well understood. The laws of gravity and the admeasurements which have been made in different places on the same meridian have demonstrated to us that the greatest mathematicians have mistaken its real figure. Various theories have at different times been published and refuted, and others substituted in their stead. Yet still a shade of darkness and mystery appears to hang over the subject. For many principles, attractions, and apparent variations from the established laws believed to exist in the economy of nature have been discovered, particularly in the polar regions, which remain unexplained and unaccounted for. Let us, therefore, examine and investigate any theory which proposes to explain them. Let us not be so tenacious of our own opinions and hereditary prejudices as to stop at the very point where everything invites us to proceed. Let us rather push our researches after knowledge to the utmost, and exercise our reason and every means in our power that may tend to the advancement of science and knowledge. In the pursuit, let us not be retarded by the cry of prejudice or the sarcastic whispers of the narrow-minded and selfish. Let us, therefore, give Captain Symmes a gentle meeting and a candid hearing in the following short chapters. Ascertain what his theory is and on what principles he supports it, and then adopt or reject it as our reason may dictate. Symmes's theory, comprehending his description of the form of the Earth and of the other orbs in the universe, his principles of gravity, and the points wherein he differs from the old or generally received theories. According to Symmes's theory, the Earth, as well as all the celestial orbicular bodies existing in the universe, visible and invisible, which partake in any degree of a planetary nature, from the greatest to the smallest, from the sun down to the most minute blazing meteor or falling star, are all constituted in a greater or less degree of a collection of spheres, more or less solid, concentric with each other, and more or less open at their poles, each sphere being separated from its adjoining compeers by space replete with aerial fluids. That every portion of infinite space, except what is occupied by spheres, is filled with an aerial elastic fluid, more subtle than common atmospheric air, and constituted of innumerable small concentric spheres, too minute to be visible to the organ of sight assisted by the most perfect microscope, and so elastic that they continually press on each other and change their relative situations as often as the position of any piece of matter in space may change its position, thus causing a universal pressure which is weakened by the intervention of other bodies in proportion to the subtended angle of distance and dimension, necessarily causing the body to move towards the points of decreased pressure. It is a sound principle of philosophy that the particles of the common air of our atmosphere are of a repellent quality and mutually repulse each other. The whole system of pneumatics goes to prove that air presses equally in all directions. Not a single experiment in this branch of natural science can be performed that does not depend on such a property. This being the case, if the boundless extent of the universe, beyond the limits of our atmosphere, be an entire vacuum, why should the atmosphere be retained in its present circumscribed form and not expand, by virtue of its repellent quality, far beyond its known height? To prevent this, Symmes believes universal space to be filled with an elastic fluid, inconceivably rare, and uniformly distributed throughout, differing from common air and from the elastic fluids, which also are known to be repellent, existing in our atmosphere. This tendency is what Symmes believes should be understood by the term gravity, the laws of action governing which he holds to be true, as defined by Newton. And he moreover holds that the application of the laws of gravity, as laid down by Newton, leads a reasoning mind to the belief of concentric spheres, with open poles, as all planetary bodies are in his opinion formed. In regard to the effects of gravity, he pretends not to differ from the generally received opinion of the age, but the application of them as to the inner parts of insulated bodies has enabled him to improve in a knowledge of the formation of planets, and finally led him to form a correct idea of what constitutes gravity. The author of the new theory entertains a belief that the principles of planetary orbicular forms, developed by him, extend as well to the molecules of the most subtle fluids as to the innumerable stars or suns of the universe and all their planetary trains. He contends that, though he may not have discovered any new principles in physics, yet that he has made interesting advances in a knowledge of the application of what was heretofore known. According to him, the planet which has been designated the Earth is composed of at least 5 hollow concentric spheres, with spaces between each, an atmosphere surrounding each, and habitable as well upon the concave as the convex surface. Each of these spheres are widely open at their poles. The north polar opening of the sphere we inhabit is believed to be about 4,000 miles in diameter, and the southern above 6,000. The planes of these polar openings are inclined to the plane of the ecliptic at an angle of about 20 degrees, so that the real axis of the Earth, being perpendicular to the plane of the equator, will form an angle of 12 degrees with a line passing through the sphere at right angles with the plane of the polar openings. Consequently, the verge of the polar openings must approach several degrees nearer to the equator on one side than on the other. The highest north point, or where the distance is greatest from the equator to the verge of the opening in the northern hemisphere, will be found either in the Northern Sea, near the coast of Lapland, on a meridian passing through Spitsbergen in about latitude 68 degrees, or somewhat more eastwardly in Lapland, and the verge would become apparent to the navigator proceeding north in about latitude 90 degrees.
The lowermost point, or the place where the distance is least from the equator to the verge of the northern polar opening, will be found in the Pacific Ocean about latitude 50 degrees near the northwest coast of America, on or near a meridian running through the mouth of Cook's River, being in about 160 degrees west longitude, the real verge being in about latitude 50 degrees and becoming apparent to a person traveling northward at right angles with the magnetic equator at the distance of about 1,200 miles further. The verge varies progressively from the lowest to the highest point, crossing the northwest coast of America between latitude 52 and 54. Thence across the continent of North America, passing through Hudson's Bay and Greenland near Cape Farewell. Thence by Mount Hecla to the highest point, thence tending gradually more to the south across the northern parts of Asia, at or near the volcanoes of Kamchatka, and along the extinguished volcanoes of the Fox Islands, to the lowermost point again, near the northwest coast. In the southern hemisphere, the highest point or place, where the distance is greatest from the equator to the verge of the polar opening, will be found in the southern Pacific Ocean, in about latitude 46 degrees south, and perhaps about longitude 130 degrees west. And the lowermost point or place, where the distance is least from the equator to the verge of the opening, will be found on a meridian south or southeast of the island of Madagascar, in about latitude 34 degrees south and longitude about 50 degrees east, thence passing near the Cape of Good Hope, across the Atlantic Ocean and southern part of the continent of America, through a chain of active volcanoes to the highest point, thence bearing regularly toward the lowest point, passing between the 2 islands of New Zealand, or across the most southerly one and the northernmost part of Van Diemen's Land, to the lowest point, which is south or southeast of Madagascar, the apparent verge being several hundred miles beyond the real verge. Consequently, according to this formation of the sphere, the degrees of latitude on different meridians will vary according to their distance from the polar openings, and the magnetical equator, which encircles the sphere,
parallel to the plane of the polar openings would cut the real equator at an angle of 12 degrees. A person standing on the highest part of the apparent verge would appear to be under the polar star, or nearly so, and at the 90th degree of latitude. The meridians all converge to the highest point of the verge, or the 90th degree. Consequently, in tracing a meridian of longitude, you would pursue a direction at right angles to the equator until you arrived in the neighborhood of the real verge of the polar opening, when the meridians would change their direction and turn along between the real and apparent verges towards the highest point until they all terminated at the 90th degree of latitude, this being the direction a person would travel in order to have his back to the sun always at o'clock, the time of his greatest altitude. Although the particular location of the places where the verges of the polar openings are believed to exist may not have been ascertained with absolute certainty, yet they are believed to be nearly correct, their localities having been ascertained from appearances that exist in those regions, such as a belt or zone surrounding the globe where trees and other vegetation, except moss, do not grow. The tides of the ocean flowing in different directions and appearing to meet, the existence of volcanoes, the ground swells in the sea being more frequent, the aurora borealis appearing to the southward, and various other phenomena existing in and about the same regions mark the relative position of the real verges. The heat and cold of the different climates are governed by their distance from the verge of the polar opening and do not depend on their nearness to or remoteness from the equator. The natural climates are parallel to the planes of the polar openings and cut the parallels of latitude at an angle of 12 degrees. When the sun is on the Tropic of Capricorn, the circle of greatest cold would be about 23.5 degrees south of the apparent verge. And when the sun is on the Tropic of Cancer, this circle would probably be just under the umbrage of the real verge. Hence it follows, if this doctrine be correct, that the climate of 40 degrees north latitude on the plains of Missouri in the western part of the continent of America will be as cold in winter as the latitude of 50 or 52 degrees in Europe, and observation has fully confirmed such to be the fact. The magnetic principle which gives polarity to the needle is believed to be regulated by the polar openings, and that the needle always points directly to the opening and of course parallel to a line drawn perpendicular to the plane of the opening. And when the apparent verge shall be passed, the needle will seem to turn nearly round so as to point in an opposite direction, having the contrary end north on the interior of the sphere that was north on the exterior, the same end being north on the interior which was south on the exterior. Hence, when navigators arrive in the neighborhood of the apparent verge, the variation of the needle becomes extreme, and when the verge is passed, the variation is more or less reversed. The meridians run from the highest northern to the highest southern point on the verges. Hence, in tracing a meridian or sailing due north, we would pursue that line which would conduct us directly from the sun at his greatest altitude. And when we come to the verge and wind along the vicinity of the edge of the real verge until it brought us to the highest point of the apparent verge, the magnetic needle, on arriving at the verge, would appear to cease to pursue the same direction, but would in reality continue to maintain it and lead directly into the polar opening. According to this formation of the sphere, a traveler or navigator might proceed true north anywhere west of the highest point of the verge, say on the continent of America, until he come to the verge. The meridian on which he was traveling would then wind along the verge to the right until he arrived at the 90th degree, and by proceeding south in the same direction, he would arrive at the coast of Siberia without going far into the concavity of the sphere, and without knowing that he had been within the verge. Should such a journey be effected, it would appear to confirm the old theory of the form of the Earth and put the subject at rest, although pursuing the needle might have directed the traveler into the interior and enabled him to discover those fine countries which Captain Symmes alleges to exist there. Each of the spheres composing the Earth, as well as those constituting the other planets throughout the universe, is believed to be habitable both on the inner and outer surface, and lighted and warmed, according to those general laws which communicate light and heat to every part of the universe. The light may not, indeed, be so bright, nor the heat so intense, as is indicated in high northern latitudes, about where the verge is supposed to commence, by the paleness of the sun and darkness of the sky, facts which various navigators who have visited those regions confirm. Yet, they are no doubt sufficiently lighted and warmed to promote the propagation and support of animal and vegetable life. The different spheres constituting our planet and the other orbs in creation most probably do not revolve on axes parallel to each other, nor perform their revolutions in the same periods of time, as is indicated by the spots on the belts of Jupiter, which move faster on one belt than another. The atmosphere surrounding the sphere is probably more dense on the interior than the exterior surface, the increased pressure of which must increase the force of gravity, as the power of gravity must increase in proportion as we approach nearer the poles. Clouds formed in the atmosphere of the convexity of the sphere probably float in through the polar openings and visit the interior in the form of rain and snow. And the long continuation of winds, or regular monsoons, which occur in some parts of the Earth, may be supplied by winds sucked into one polar opening and discharged through the other, thus performing the circuit of the sphere. Without which supposition, it would be difficult to account for the long continued winds which, at certain seasons, are known to blow constantly for several months, more or less obliquely to and from the poles. The disciples of Symmes believe that each sphere has a cavity or mid-plane space near the center of the matter composing it, filled with a very light, subtle, elastic substance, partaking somewhat, perhaps, of the nature of hydrogen gas, which aerial fluid is composed of molecules greatly rarefied in comparison with the gravity of the extended or exposed surfaces of the sphere. This mid-plane space tends to give the sphere a degree of lightness and buoyancy. Besides this large mid-plane space, perhaps numerous other interstices exist in the sphere nearer the surface, and of more limited extent. The gas escaping from these spaces is no doubt the cause of earthquakes, and supply the numerous volcanoes. This gas becoming rarefied and escaping must occasion most of those great revolutions and phenomena in nature which we know to have occurred in the geology of the Earth. This aerial fluid with which the mid-plane spaces are filled may possibly be adapted to the support of animal life, and the interior surfaces of the spheres formed by them. In many parts of the unfathomable ocean, there may be communications or passages from the surface of the sphere on the outer side to the surface of the inner, at least all except the great mid-plane space, through which liquid apertures, light and heat may be communicated perhaps to the interior surface of the sphere. Symmes' theory, supported by arguments drawn from the principles inherent in matter and the consequences resulting from motion, tending to show that, from necessity, matter must form itself into concentric circles or spheres, such as Symmes describes the Earth to be composed of. It is a principle laid down by Sir Isaac Newton, the correctness of which is generally admitted, that matter attracts matter in proportion to its quantity and the squares of its distances inversely. Captain Symmes contends that gravity consists in a certain expansive quality in the molecules which constitute the aerial fluid called ether, which fills universal space and creates a pushing instead of a pulling power. However, let either be correct, I conceive it cannot materially affect the principles necessary to constitute concentric spheres. Either principle, I apprehend, would lead us nearly to the same results. When matter was in chaos, or in a form not solid, promiscuously disseminated through universal space, suppose it then should at once receive the impression of those universal laws by which it is governed, and see what would be the consequence. According to Sir Isaac Newton's principles of gravity, the particle of matter that happened to be the largest would attract the smaller in its neighborhood, which would increase the power of attraction in proportion to the increase of matter, until all in the universe would be collected into one vast body in the center of space, and there remain motionless and at rest forever. This, however, we find not to be the case, for innumerable bodies of matter, differing in magnitude, are known to exist throughout the universe, arranged at suitable distances from each other, and performing certain revolutions in obedience to certain fixed laws impressed on them. Now suppose all the matter in our globe to be an extended liquid mass, the particles so disengaged from each other as to take their positions according to the established laws of matter, and then see what would be the consequences resulting from motion and gravity. Taking the laws of Newton for our guide, the particles of matter in the center would be operated on by the power of gravity equally on all sides, and consequently be stationary. Suppose then a line struck through this globe of matter, so as to make a globe of half the diameter of the whole in the center. It is plain that the inner globe would not contain more than 1/8 part as much matter as the surrounding one. Hence, it would be attracted towards the surface more than to the center, were it not for the attraction of the matter on the opposite side exerting an influence upon it. But this being removed to so much greater distance would not be more than an equipoise to the other. The diameter of our globe, according to the best observation, is believed to be about English miles, and its circumference on 38. Consequently, if it were solid, it would contain 1,78,559,622 cubic miles of matter, while a globe of only half the diameter would contain only 134,819,952. Suppose our globe divided into parts of 1 square mile on the surface, bounded by straight lines converging to a point at the center, as the subjoined figure represents. And then suppose there were no other particles of matter in the universe but A and B, A containing 328 cubic miles of matter, and B only. A would attract B so as to make their center of attraction at O, which point would become at once the common center, but admitting the whole matter of the globe to exist, A would still exert its influence on B, but both would be operated upon by T and S and the surrounding matter, all, perhaps, tending to one common center. However, I imagine that the tending to the center would not be so great as is contended for by the generally received theory, which alleges that matter at the center of the earth is 4 times as hard as hammered iron. The Newtonian philosophy appears to contemplate a globe at rest, and not in such rapid motion as we know the earth and other planetary bodies to be in, communicating to them a centrifugal force which tends to throw matter from the center. The rotary motion of each planet is no doubt regulated by the quantity of matter it contains, so that at its surface, centrifugal and centripetal forces are equally balanced, the rotary motion being adequate to communicate a force to counterbalance the force of gravity. Newton, ascertained by his investigations of the properties and principles of matter, the Earth to be a globe flattened at the poles, and the French philosophers afterwards confirmed this fact by measuring a degree in different latitudes. This difference between the equatorial and polar diameters of the Earth and of the other planets which are also known to be of that shape is ascribed by those philosophers who attempt to account for such a formation to the projectile force of the globe at the equator occasioned by its rotary motion. This is admitting that the matter of our globe was once in so soft a state as to take its form from motion. For were the Earth a compact solid body, and 4 times as hard as hammered iron at the center, as the Newtonian system alleges, this rotary motion round an imaginary axis could never give to the globe the form of an. But were the matter of this globe thrown into a confused, disorganized state, and then put into a quick rotary motion, such as it is known to have, it would throw off from the center towards the surface, first the heaviest, and next the lighter substances, which is the very order in which they are found to be arranged in the composition of the Earth. This principle, for it is simply the principle of projectile force, will account for mountains, hills, valleys, plains, and for nearly all the inequalities on the face of the Earth. These circumstances depend on the density of substances composing the Earth. Substances of the greatest specific gravity are susceptible of the greatest projectile force, and hence we find that mountains are composed of heavy masses of rock, mineral substances, and heavy earths. Hills, or the next highest eminences of earth of the next specific gravity, and plains, or level lands of lighter substances. Had the Earth originally been composed of one uniform substance, sand, for example, of equal fineness and weight, the whole surface of the globe would have presented one uniform level or unbroken plane. But presuming that it was originally composed of at least earths of different densities, the heaviest masses would be first thrown out and raise their heads above the surface of the ocean. Thus islands would be formed, and clusters of islands would form continents, rearing their lofty heads into the air. And if the substances of which they were originally composed were not as hard as the rocks which we now find on them, the sun and changing temperature of the climates might convert certain kinds of earth into masses of stone, increasing in specific gravity by petrification and other causes, until the towering peaks of the Alps and Andes assumed their present solid form. One continent having thus emerged, another would naturally be produced simultaneously on the opposite side of the sphere, as an equipoise to the first, to keep equal the Earth's motion, until all the heavy substances should be thrown out and united in a compact sphere. To an observer of the Earth, the crust everywhere appears to indicate the emergence of land from water. Almost the whole surface of the solid crust is alluvial, and by reasoning and reflecting, we are led to the conclusion that the solid parts of our globe are nothing more than a crust, and formed into concentric spheres in accordance with the principles of projectile force. I would ask, what proofs have we that the sphere we inhabit is solid beyond the degree of thickness necessary to preserve it from injury by its rapid motion round the sun, by its diurnal motion round its own axis, and by its motion round its common center of gravity with the moon? It has been ascertained with mathematical certainty that the large planet Jupiter is more than times the bulk of the Earth, and Saturn, independent of his double ring, is about times the size. If we apply to those prodigious bodies the reasoning of Newton relative to plastic forms moving variously, there is no just grounds for concluding that they are solid substances to their centers. If they were, their vast weight and remote position would require much more attraction than probably even the sun could furnish to keep them within their orbits. The acknowledged and received laws of gravity, together with the measurements made on the same meridian in different latitudes, have demonstrated to us that the greatest mathematicians have been mistaken as to the real figure of the Earth. It is for schoolmen to make exact calculations respecting the force of gravity and centrifugal and centripetal forces. It is for them to determine with mathematical certainty where matter left to its own laws would settle. For such undertakings, I acknowledge my incompetency. But I have long had strong doubts whether the laws of gravity are well understood, or whether the rules on which these calculations could be accurately made are exactly known. However, I take the broad principles of observe the boy hurling a stone from a sling. He whirls it round his head for a minute to acquire a certain degree of centrifugal force, and although it is not whirled with half the velocity the earth revolves on its axis, yet as soon as it is released from confinement, notwithstanding the whole power of the earth is operating on it with all the force of gravity, the centrifugal force which the stone acquired by the whirling is sufficient to carry it off, at a tangent to the circle described by the sling, for a very considerable distance, before the gravity of the earth and atmospheric obstruction can force it to the ground. If you will take the trouble to examine a mechanic grinding cutlery on a large stone that is smooth on the sides and has a quick motion, you may observe that if a certain portion of water be poured on the perpendicular side whilst the stone is turning, it does not settle or form itself into a body round the crank or axis, nor does the gravity of the earth draw it from the surface, but forms itself on the side of the stone into something resembling concentric circles, one within another. The surface of the earth, I apprehend, revolves with much greater velocity than any grindstone, and the substances composing the spheres are much firmer than water. Most of us, I presume, have seen persons for amusement, in displaying feats of dexterity, place a full glass of wine or water on a hoop and whirl it round their heads without spilling one drop. The centrifugal force it acquires by the revolutions overcomes the power of gravity, although nothing appears to support it but the common atmosphere. Another experiment, producing a similar effect, might be made with a cup filled with fine sand. On the surface of the sand, describe a circle nearly in the center. It will then be apparent, on observing the cup, that the sand within the circle, provided the particles attract one another as the planets do, is as much attracted towards one verge of the cup as the other, owing to its being equally surrounded by matter or sand, and therefore it can be but very little, if any, gravitated center-wise. Hence, being in a degree suspended, only a small horizontal rotary motion is required to whirl it towards the rim or sides of the cup into a circular form, and hence it follows that those particles of sand lying equidistant from the inner side of the circle of sand thus formed, and the outer side, would be in like manner balanced or supported by being equally gravitated in both directions. A disposition would thus be produced to form into concentric circles, and it would therefore follow that successive similar dispositions to subdivision should occur, gradually lessening in force and quantity. This principle applied to the Earth or other planets would cause them to be formed into concentric spheres, and would throw the matter from the... Another simple experiment might also be made to illustrate that a disposition to concentric spheres does exist in nature. On a piece of paper, sift a small quantity of very fine magnetic particles, such as steel or iron filings, under which hold a lodestone, and you will observe that the attractive power of the magnet will cause the filings on the paper to arrange themselves into various concentric circles, nearly regular and equidistant from each other. From what cause should this take place, rather than that the filings should be accumulated into one mass? Various have been the conjectures relative to the cause and origin of the meteoric stones, or fireballs, which have been known to fall to the earth in all ages and in various parts of the world. Some have imagined them to be precipitated from a comet or some of the planets, others that they come from the moon. And Captain Symmes's opinion, I believe, is that they are formed isolated in space by spontaneous accumulations, as by attracting molecules of matter at first in a fluid state, which afterwards solidifies by heat or motion. But come from whence they may, they are said to be constituted of a substance unknown to our geologists, and in several instances, the fragments have been ascertained to consist of pieces, some of which have concave and some convex surfaces, affording a certain proof that previous to their descent, they had been constituted of hollow spheres. Professor Silliman of Yale College has preserved some of the fragments of one of these fireballs, and in his valuable journal has given the public an able description of the facts which occurred when they fell. This fireball fell in the state of Connecticut in the year, producing 3 distinct reports, like a cannon making 3 convulsive leaps or throws in its course, which were simultaneous, no doubt, with the explosions, becoming less luminous after each and being quite extinguished at the third. 3 showers of stones fell to the earth in a line with its course. The second shower fell 5 miles distant from the first, and the last 3 or 4 miles from the second. Some of the fragments were found to be concave, others convex, and especially on those sides of the fragments which were glazed with sooty-crusted surface, as if vitrified. These phenomena are precisely such as would occur, supposing the fireball to have been a small satellite or erratic planet at first fluid, which had become so condensed by the increased action of terrestrial gravity occasioned by its sudden approach, as to cause its fluid parts to crystallize and form into at least 3 concentric spheres, and the latent heat and light set free by such rapid condensation as to produce the meteoric flame, which, in this case, was almost equal in light to that of the sun at midday. As soon as the spheres became sufficient to prevent the heated aerial fluid contained in the mid-plane cavities of the spheres from passing out with freedom, when expanded by the heat, or let the atmospheric air pass in case a condensation within afforded a vacuum, the solid crusts of the spheres would be disruptured successively one after the other, lose their regular rotation, and fall in fragments to the earth. The fall of this body is not a solitary instance of the kind. Others have fallen in many parts of the earth, attended with phenomena more or less the same. On the 16th of January, 1818, in Florida, near Mobile Bay, a fireball bursted with a considerable report. Immediately before the explosion, it was observed to project a cone of fire from each pole, horizontally and at right angles with its course. Its bursting like a bombshell indicated that it must have been hollow, and the 2 cones of light which appeared beside its train showed that it was open at the poles. Turn your attention to the general economy of nature throughout her works, and you will perceive in various and almost innumerable substances that she forms hollow cylinders or spheres in the room of solid ones. Inquire of the botanist, and he will tell you that the plants which spring up spontaneously, agreeable to the established laws of nature, are hollow cylinders. If a hollow globe would answer the ends of supporting organic life, as well as a solid one, why not be hollow as well as a stalk of wheat? Or by what laws is the stalk of wheat governed, that it should always grow hollow? What law in nature causes the quills and feathers of a bird to be hollow cylinders? Why are they not solid? I presume it is for this plain reason that nature, throughout all her works, has wisely assigned to everything just matter enough for strength and usefulness, and has in no case overburthened it with unnecessary and cumbrous weight. Inquire of the anatomist, and he will tell you that the large bones of all animals are hollow, and particularly that the bones of birds are more than ordinarily so. Even the minutest hairs of our heads are hollow. Go to the mineralist, and he will inform you that the stone called aerolites and many other mineral bodies are composed of hollow concentric circles, and that strata of different kinds abound in various mineral substances. Even the earth itself is composed, as geologists tell us, of various strata, composed of different substances and varying from one degree of density to another. If every part of our globe be regulated according to the received laws of gravity and the relative density of matter, why do we find almost all over the world light alluvial soil in the valleys and plains, and on the tops of the highest mountains, the more heavy granite and some of the heaviest substances that nature knows? However, if we direct our attention alone to those general laws which are known, and which are believed to govern matter, I apprehend it would be very difficult to account for the creation of worlds, and the admirable arrangement which subsists throughout the universe. To account for everything, either according to the old or new theory, would be attempting too much. It would be placing the deity in some corner of the universe, an idle spectator, whilst matter, governed by its own laws, was forming itself into worlds and systems, the bare thought of which is irreverent. Is the existence of matter owing to some other first cause, or did matter create itself, and impress upon itself the laws which govern it? Such an idea is absurd. We might as well imagine that matter created God as itself. By attempting to trace every effect to some natural cause, is attempting to do more than we shall ever be able to accomplish. Such a course of reasoning must lead us to the conclusion that there is no God or first cause, or at least to what would be nearly the same thing, that there is no need of one. But in reasoning upon this subject, I take it for granted that there is a God, and that he is the first cause of all things, the creator of all the orbs in the universe, be they either solid globes or concentric spheres, and I hope such is the reader's belief. And I cannot discover in this anything derogatory from his infinite power, wisdom, or divine economy in the formation of a hollow world and concentric spheres, any more than in that of solid ones. I should rather be of opinion that a construction of all the orbs in creation on a plan corresponding with Symmes's theory would display the highest possible degree of perfection, wisdom, and goodness, the most perfect system of creative economy, and, as Dr. Mitchell expresses it, a great saving of stuff.